Good afternoon, Austin. It's been a wonderful last 4 days. It's been a great hospitality. Happy to be here. I'm with EMC's Core Technologies division. Today, we're going to talk about EMC XtremIO all-flash storage. Really, there's been a lot of talk about microservices and containers and Platform 2 applications and Platform 3 applications. Although I'm going to talk about storage because all of this thing needs to live on storage. And reality has fundamentally changed for storage. So I think it's important to get a storage perspective because your storage can bring your private cloud, OpenStack private cloud, to crawling halt. So what's really happened in the enterprise data center, right? Data centers have gotten denser and denser over time. Today you may have hundreds, if not thousands of VMs in a data center trying to access centralized shared storage. That was not the reality a few years ago. So what happens when you have such a dense environment, number of virtual machines accessing shared infrastructure? Storage. Really, hypervisor essentially chops up all that traffic going to the storage, randomizes it in small block, really high random IO requests. Really, storage was not designed to do this kind of activity. It's small block random access, really high frequency. Storage can become a real bottleneck here. That's something that's known in the industry as IO blender effect. It's really blending the IOs, like chopping the IOs and blending them together. Really not an ideal workload for storage. So fundamentally, the workload has changed for storage. Secondly, one of the key requirements of a private cloud is self-service. A lot of times it may be your end user self-servicing, it may be lines of businesses self-servicing their needs. Really, the VM admins or the guys who monitor and manage these virtual environments have no control over when these operations are going to happen. And this provisioning and cloning VMs, it's extremely storage intensive activity. Imagine you have multiple VMs. You have a VM, say, multiple gigabytes, and you want to make several copies of that. All of that data has to be read and written back to the disk. It steals a whole lot of IOs from your storage. Those IOs actually should be preserved for serving the workload, not for dump copy operations. So that's something really new for storage to deal with. And then lastly, the environments have become extremely dynamic, and that's, I think, the gist of the private cloud, right? You want to be able to automate all of the activities, so the manual intervention is minimal. So things like moving the VMs around on storage tiers, bringing up the VMs or bringing down the VMs based on policies has become very commonplace. Really, again, not something that administrators trigger. This is something that policies trigger. So you have no control when this is going to happen on the storage tier. And so storage, actually, it's become extremely unpredictable for a storage administrator to understand what's going to happen with the storage when. And this kind of workload was not really designed. Storage was not designed for this kind of workload. Storage, fundamentally, the storage architectures have been constant for the last 15, 20 years. There may have been incremental changes, but fundamentally the architectures haven't changed. So storage often becomes a bottleneck. It's always an afterthought, but it can become the bottleneck of your infrastructure. So that's what it means, actually. Storage can be a bottleneck, and really, in today's reality, you need a new kind of storage that is designed for this new normal to handle this massive VM workloads in a manner that is extremely transparent to the infrastructure above it. So I'm going to talk about a little bit about XtremIO. XtremIO was designed for this new reality. It was ground up built for the private cloud virtualized world. It was built ground up to take advantage of all flash media. It's not a retrofitted storage platform. It's fundamentally a different architecture for today's new normal. So when flash first came to the market, really the first thought for many vendors, and I think it's logical to have that thought, is we can go a lot faster now. It's a great media. You can get a whole lot of IOPS. You can reduce the latency, and we can go faster. Well, that's true, but you can do a whole lot more with flash. It fundamentally opens up new possibilities about thinking about storage and what you can and cannot do with storage. So when XtremIO looked at it, we thought, yeah, let's go fast, but let's see if we can get more smart about storage, how storage serves the workloads, the fundamentally different workloads of today's new normal. And maybe put together, it will unlock some unique business values, and it will give the companies competitive advantage in whatever endeavor they're set to do. Right, so what is, essentially these four quadrants, in my opinion, kind of define what XtremIO is. So first one, the scale-out architecture. I think it's essential in today's world. Even today, most of the storage platforms are scale-up kind of storage platforms. I think scale-out is a critical element of today's infrastructure. So what I mean by scale-out is, you have this building block kind of approach. Each building block is self-contained, has its own controller resources, has its own capacity resources that drives, and you scale in the boxes. So you're scaling your performance and your capacity together in a predictable manner. So that's one. The second one is the data services. All of these data services XtremIO offers, they're offered inline all the time. And partly The scale-out architecture is here, is the reason we can do that inline all the time without any performance degradation. There are many other platforms who don't follow the scale-out paradigm, and they cannot deliver these services without compromising something else. And then third, the copy data management, which you see on the right, top right quadrant, copy data management. So if you think about snapshots that are XtremIO virtual copies, and what you can do with them. Those copies are virtual copies. If you can manage those copies really efficiently, if you can refresh those copies on the fly, and if you can integrate that copy operation, the storage-based copy operations, to application interfaces, so your Oracle guy can use the storage capabilities. That's copy data management. Integrated copy data management is something that XtremIO was the first to define. There have been copy data management solutions, bolt-on, but we were the first one to essentially say this is something that belongs at the storage layer inside the storage controllers, because storage has the intelligence to deliver it more efficiently. And then lastly, the application and data center services ecosystem that we have. Being part of EMC, we can integrate into a whole lot of other data center services for data protection, for continuous availability, for disaster recovery, and things of that nature. But we also work really nicely with partners like VMware, like Red Hat for OpenStack, like Mirantis, like application partners like Oracle and SAP, to make sure that our storage platforms are really well integrated and optimized for those workloads. So what's in an XBrick? It's a building block, and you scale in the form of an XBrick. So XBrick essentially has some capacity resources and some controller or processing resources. It has two active controllers. Each controller has massive amount of RAM. It has at least, between those two controllers, you have at least a half a terabyte of RAM. If you're looking at 10 or 20 terabyte XBrick. If you're looking at 40 terabyte XBrick, you're looking at about a terabyte of RAM. It has at least 32 CPU cores between those two controllers. And these are two active controllers working all the time. It's not active-passive architecture, so you're not wasting any resources. And then finally, you have 25 enterprise-class MLC drives delivering that capacity. Irrespective of the size of the XBricks, XBricks are available in 10, 20, and 40 terabyte versions. The number of drives remain the same, 25. And so you scale essentially by adding XBrick by XBrick. So as you can imagine, you're doubling your capacity resources. By adding an XBrick, you're also doubling your controller resources. Instead of 2, you have 4 controllers now. Right, so let's look at why scale-out matters, especially in today's world. So scale-up has been an approach, has been around for a long, long time. This is how scale-up works. So you have a SAN, you have 2 controllers. One is active, one is passive. Really, you're using half of your controller resources. Half of the controller resources are wasted just waiting for the other one to fail. And you have capacity in the form of disk enclosures. You need more capacity, you add more disk enclosures. Really, you're not scaling, you're not changing your controller resources, the ones that are responsible for performance. You're not changing them even though you're growing your capacity. So as the scale grows in this architecture, the ratio of controller resources, so the processing power, to capacity deteriorates over time. And as that really becomes a bottleneck as the scale grows beyond a certain point. Another thing to keep in mind is, it was really fine. This architecture was okay in the age of spinning media, because those spinning disks often used to be the bottleneck. They were not able to deliver enough amount of IOPS, so rarely controllers became bottleneck. But now you change that to Flash. Flash can do a whole lot more IOPS at a much lower latency than spinning media. So now your controller becomes bottleneck. So what's the point in having a fast media if you're going to choke it at the controller layer? So that's a fundamental problem with the scale-up architecture in today's world. So XtremIO solves that with a scale-out architecture. So this is called an XtremIO cluster or an array. In an array, you can have up to 8 XBricks. You can have up to 16 controllers. Every XBrick has 2 controllers. And you can scale it linearly, 1, 2, 4, 6, and 8. So as you're scaling capacity, you're also scaling performance. And so that's why you'll see IOPS scale linearly. So you can get up to 2 million read IOPS or 1.2 million mixed IOPS, 50-50 read-write, 8 KB. These are not hero numbers, realistic numbers, while keeping latency below a millisecond. You can get up to 1.2 million IOPS, mixed IOPS, or 2 million read IOPS. And they scale linearly. So you can predict how your array is going to perform, how many XBricks you need to deliver certain performance. Another thing with scale-up architecture is you have 2 controllers, right? And metadata is the most important thing. Metadata is the intelligence about the data. If you have just 2 controllers, as you add more and more capacity, your data grows, your metadata grows. Eventually, you run into a situation where your controllers cannot keep all of that metadata. So they have to destage that metadata onto the drives. right? So every time you have to do something intelligent with the data, you have to fetch that from the disks into the controller RAM, do the manipulation, write it down. So it does a couple of things. You cannot do certain things like inline deduplication without degrading the performance, because they have to fetch and refetch the metadata all the time. It also means that the metadata cannot be granular, it has to be chunky. XtremIO essentially solves that with this scale-out architecture, right? So you have, in this case, you have 4X bricks, 8 controllers. They're all connected together with RDMA fabric, backend 40 gig RDMA fabric. All of the metadata lives in a memory. So you can do neat stuff. You can take snapshots, and snapshots by definition are duplicate. So it's all metadata operation. Nothing happens on a drive, on a disk layer. Data plane, there's nothing happening. You can also do a whole lot of stuff in memory, in the metadata without bothering the drives. So put it all together, you get an architecture that scales predictably, that performs predictably, and it requires absolutely no tuning. There is no concept of RAID. We have a different data protection. There is no tiering. You don't have to count the spindles. Every volume goes across all available resources. All of it, not one thing, not only flash, not only scale out, all of it put together delivers you an architecture that is really optimized for today's private cloud realities. So these are the data services. Thin provisioning. Every volume by definition, by default, is thin provision. Deduplication is done inline all the time. It's global, not only within the volume, not only within the brick, but it's across all available data in the cluster. If there's data already exists, it's just going to be a metadata operation. There won't be any data written. Compression is also done inline. So databases who don't dedupe compress really well. XtremIO data protection. It's a scheme that we developed for Flash. Gives you performance better than any other RAID level. Has really low overhead. And takes the guessing about RAID away. And then encryption is done right on the drives. So drives are self-encrypting, so there's no overhead, there's no performance overhead or cost overhead. And then XtremIO virtual copies, essentially the snapshots. You can take snapshots of volumes, VMs, databases, name it. Snapshots happen in the metadata. So what can you do with it, right? Cloning a VM is quite a common activity. You can clone a number of VMs. You have a VM here being cloned. It's all happening in the metadata, so it's happening at a RAM speed. Blazing fast. And the most important thing is it's not taking any IOs away from drives, because there's nothing happening on a data plane. It's all in the controller RAM. So if there's a workload running, that's not going to start crawling because somebody's triggered 500 copies of a virtual desktop. On the database side, you have sprawl. You have a production environment that usually translates into many folds by the time you're done with test, dev, QA, and all of those copies. Right? 10 terabytes usually means 70 to 100 terabytes by the time you're done with all the ancillary copies. With XtremIO, you essentially shrink it to 5 terabytes because of compression. All the other copies are free, and they're instant. They're immediate. You can refresh them on the fly. So extremely flexible, agile workflows you can build around it. REST APIs. So we do support open REST APIs, and we use it actually ourselves in our Cinder driver. And I'm going to quickly show you the Cinder features that we've added over time, just to show the commitment that we have. We started with Juno. We started, these are the features we had in Juno. Incrementally, we added these features in Kilo. In Liberty, we added 2 more features. Over time, we are advancing what our Cinder drivers can do. In METADATA, we're already working on that. And this is something that's going to come in METADATA. And as for reference architectures, we're working on right now on the reference architecture with OSP7. Red Hat OSP7 should be out in a month's time in the form of a white paper. We also worked with VMware on their VMware integrated OpenStack. Did this reference architecture with them. Quite astonishing results, right? The control plane deployment, blazing fast. 60% faster control plane deployments. Image imports really fast. Cloning VMs, provisioning VMs, at the speed of light, essentially. Because everything happens in the metadata. There's actually no copy operations going on the data plane. So I would say, storage architectures need to change for today's reality. XtremIO is designed for those today's reality. Scale out, all flash, in-memory metadata, zero penalty copy services. That's what defines XtremIO, and that's what is needed for today's private cloud environment. It's exceptionally simple. There's absolutely no tuning, no spindle counting, no performance optimization, no guessing your RAID, none of that stuff. And we are committed to OpenStack. We've been working with OpenStack for a long time, and we're committed to keep continuing collaboration with the OpenStack community going forward. Thank you. Thanks for listening.